What if a planet could be discovered by making the sky flicker, then quietly lose its title? Pluto's story is exactly that. It begins with hope, turns into debate, and ends with one of the most breathtaking visits in space history. This is the story of a tiny world that changed astronomy forever. In the early 20th century, the outer solar system felt unfinished. Astronomers knew Neptune existed, but they also suspected something else was tugging at the edges of its motion. They called it Planet X, a hidden world that might explain the mystery. For years, it was only an idea. Then, in Arizona, one young observer found a real dot moving where it shouldn't. On February 18, 1930, 24-year-old Clyde Tombaugh was working at Lowell Observatory, comparing photographic plates of the same patch of sky. He used a simple method called blinking. One plate, then the other. One star field, then the next. Most points of light stayed still. One tiny speck did not. It shifted. That tiny shift changed history. The discovery was announced on March 13, 1930, and the world suddenly had a ninth planet. People loved the idea almost immediately. Pluto felt distant, mysterious, and noble. Even its name had a story worth telling. When astronomers discovered Pluto's large moon, Charon. That changed everything. A moon gives scientists a natural way to measure mass, because they can watch how two bodies move around each other. With Charon, Pluto's weight could finally be estimated more accurately. The answer was clear. Pluto was not massive enough to be the old Planet X idea. The legend was bigger than the object. Still, Pluto was never boring. It is small, yes, only about 2,377 kilometers across, even smaller than Earth's moon. But it is also a true world, with its own weather, geology, and dramatic orbit. It takes 248 years to circle the Sun once, swinging from roughly 30 astronomical units out to nearly 49. And for part of that journey, Pluto actually moves closer to the Sun than Neptune does. That sounds chaotic, but it isn't. Pluto and Neptune are locked in a 3-to-2 orbital resonance. Pluto goes around the Sun twice for every 3 Neptune orbits. Their motions are perfectly timed. So even though their paths cross in a cosmic sense, the two worlds do not collide. The solar system, as it turns This was the turning point. If Pluto belonged to a much larger population of similar objects, then what exactly made it a planet? The question stopped being sentimental and became scientific. The debate got sharper in 2005 when Eris was announced. Eris was another distant world, and if Pluto counted as a planet, then Eris might have to count too. Suddenly, the word planet was under pressure. In 2006, astronomers made a difficult decision. The International Astronomical Union defined a planet as something that orbits the Sun, is round, and has clear. It was one of the fastest departures ever. On board was a symbolic passenger, a small container holding some of Clyde Tombaugh's ashes. The discoverer of Pluto was, in a sense, making the journey himself. The spacecraft even carried a 1991 postage stamp that had said, "Pluto, not yet explored." The mission was designed to make that line obsolete. It took nearly a decade. Then, on July 14, 2015, New Horizons raced past Pluto at roughly 7,800 miles above its surface. It was not an orbit, it was a daring drive-by. But in that brief flyby, Pluto went from a blurry speck to a living, breathing world of ice and motion. The images stunned everyone. Pluto's brightest feature was a vast, heart-shaped region, and its western lobe, Sputnik Planitia, turned out to be a giant basin filled with nitrogen ice. It stretches about 1,000 kilometers across, and its surface looks astonishingly young. Smooth, fresh, restless. Some areas seem to churn through solid-state convection, with icy cells slowly moving like a frozen lava lamp. And surrounding that ice plain are mountains made of water ice, rising 2 or 3 kilometers high. On Pluto, water ice is hard as rock. So you get a strange landscape where soft nitrogen glaciers flow around rigid icy peaks like frozen seas meeting ancient continents. Pluto, once imagined as a dead snowball, turned out to be geologically alive. The surprise did not stop there. New Horizons found layers of haze stacked through Pluto's thin atmosphere, dozens of them in some views. It measured a surface pressure of about 11.5 microbars. That is almost nothing by Earth standards, but it was enough to shape the world. Even more surprising, Pluto seemed to be losing its atmosphere more slowly than many models predicted. Small worlds can hold secrets longer than expected. Scientists also began to suspect something deeper. The location of Sputnik Planitia may make sense if Pluto has, or once had, a subsurface ocean beneath the ice. That possibility gives Pluto an even bigger role in planetary science. It is not just a frozen relic. It may be a place where internal heat, ice, and chemistry still interact in ways we are only beginning to understand. And Pluto may still be changing today. New analyses continue to test how its ice moves, how its atmosphere shifts, and how its surface evolves. That is the real lesson of Pluto. It was never just a matter of naming a planet or removing one. It was a reminder that science is not weak when it changes. Science is strongest when it follows the evidence, even when the evidence surprises us. Pluto began as a distant point of light, became a planet, then a new kind of world. But in every stage, it stayed important. It taught us how discoveries are made, how definitions evolve, and how wonder grows when we look again. Tell us, should Pluto be a planet again?